So, hello everyone. This is the first problem of today's starter div 2. And in this problem, we are given that we have a two-dimensional grid where we can start at, like where we start at 0, 0. And we are given a binary string S of length 4. So S1 refers to the left direction, S2 refers to the right direction, S3 refers to the up direction, and S4 refers to the down direction. Then if SI is 1, that means that for that respective direction, we can move in, like we are free to move. Otherwise, if it's 0, then that means that for that respective direction, we cannot move. Now we have to find how many cells x comma y we can visit such that x and y are between like -10 and 10. So like this is a simple problem, but there are more than one ways to solve this problem. And there's a way which is like there are some ways are easier than others. Like first of all, we have 10 cross 10, right? Something like from -10 to +10, and this way also from -10 to +10. So how many rows are there and how many columns are there? Can someone quickly tell me? 21 columns, 21 rows. So what is the total count of this? 441. So this is the total number of cells. So now you are somewhere in between here, like in the middle 0, 0 cell. Let's say this. So one way is you start like you write a BFS, like not BFS. This is brute force only. You just like you are here, and from this cell, whatever cell you have visited, from that cell, just check whether in which four directions you can go. If let's say out of these, this and this is these directions, you cannot go. So just go to these two cells, mark them as visited, and then for the next time, maybe insert these in a vector or a queue, and then from these go try again going to the four directions, and if you have already visited one of these, skip it. So this is one way, but this much effort is not required for this problem. How many people did this problem using this method? Like what, see, if you're allowed to move in this direction, then we can go up, right? And if you're allowed to go in this direction, then we can, in a way, we can go to every cell in this area. Yes, no. Is this making sense? If you're allowed to go down, like in both of these directions, then I can cover all of this. Is it making sense? If I'm able to go up, down, and right. See, what I'll do, I'll go up, up, up. I'll go to the topmost cell. Then I'll go down, 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 and I'll go all of this cell. Then I go right. Then same thing, up, 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 down, 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 up, 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 down, down, down. Same thing. If now one more, like if I can go in right and left direction, then I can visit all of these. Is it making sense? Yes, no. So what you can do, if just calculate how many rows or columns you can visit. See, if you can go in a direction, let's say increase your count of rows by 10. If you can go down, increase your count of rows by again by 10, because 10 up, 10 down. If you can go left, increase your count of columns by 10. And if you can go right, increase your count of columns again by 10. Finally, your answer is simply count of number of rows that you can visit multiplied by the count of number of columns. Is it clear? Is anyone having any doubt in this? So let me show you the implementation. So the implementation is this, how to maximize this. Yep. So what I have done, I have first taken the number of test cases as input. Then I have taken string s as input. Now instead of having count r and count c, I have lr and up down, like left, right, and up down. So for zero, like since you are already like at 0, 0, that is the center row and center column, you already have this 1, 1, like you're already at one of the rows and one of the columns. Then just iterate through the string s. If it's feasible to go in, if I is less than 2, then it means that it's about left and right. So just add 10 to LR. Otherwise, for the next two, if it's 1, add 10 to up down. Finally, just multiply this. Is it making sense? Like now you can take a minute and first of all, like think about this. If you still have doubts, then we can take, like just take around 30 seconds. Is it clear to everyone? If anyone has any doubt, you can ask me right now. Otherwise, I'll move to the next problem. By the ways, don't like this is whatever I've drawn here. If you are getting confused, like this is just like you don't have to move. Like you just have to find all the cells that you can visit. So you don't have to move in one particular order. If you're from here, it basically means that you can go in these three cells. If you can, if it's allowed to go in up, down, and right. So then from this cell is allowed to move in this, like all of these. So I have drawn it like just this in one way. You don't have to go, like it is not required to go all to all the cells in one path. Like it's just simply asked if these are the moves that you can take, then what all cells you can visit. So it's just the count. Okay, don't. Now going to the next problem, we have this thing. So in this, we are given that we have a binary string t, and f of t is the number of modes of string t. Now, for example, this f101 is this. So first of all, what is a mode? So a mode is defined as the character with maximum frequency. So I'll explain this in a moment. If multiple characters have maximum frequency, all of them are said to be modes. So mode is nothing but the character with the maximum frequency. And f of t is the number of modes, like how many number of characters have the maximum frequency in string t. So in this, how many characters have the maximum frequency? 101. Only one character. One has frequency 2, 0 has frequency 1. So there is just one character, that is 1 with frequency 2. So that's why in this mode is 1. For 0, 1, the mode is 2. Why? Because two characters have maximum frequency. 0 has also one frequency and 1 has also one frequency. So mode for this is 2. Now, given a binary string s of length n, we need to compute this thing. Now, what is this? Let me explain this in a moment. Let me explain this here. We have to find sum of f of s from L to R. So basically for every substring of this string S, we need to find sum of modes. For every substring of S, we need to find sum of modes, sum of modes, sum of modes for every this thing. Now S is a binary string, so only zeros and ones will be there. So first of all, if we have a string, if we have a binary string of something like 0, 1, 0, 1, 0, if I look at any subarray, what is the possibility? Like what all possible values of modes can take place? It will either be 1 or 2. Why? 1 will be when the count of ones and zeros is not equal. When count of 1 is not equals to count of 2. And it will be 2 when count of 1 is equals to 2. Why? If both of these are equal, then I have like this in this case, I have maximum frequent character is both 1 and 0. So basically, I shouldn't write this as count 2, it is 0. So in that case, I'll get my mode as 2. Otherwise, I'll get my mode as 1 for this example. Is it making sense? Is everything clear till now? Yes, no. So this problem can be, see, since 1 is always like either it will be 1 or 2. So can I say that for every subarray, for every substring or not like not subarray, substring, in my final sum, I'll at least add 1 for every substring. Like it can be 2 also, but at least 1 will be added, right? Everybody agrees? For every substring, I'll at least add 1. So now let's just find those substrings. We just need to find those substrings, those let's say the count of those substrings, count of such substrings for which mode is 2. And then we'll add that count to our answer or our sum, what we have already calculated. Is this making sense now? Like at least 1 will be for every substring, then just count the number of substrings for which we have mode as 2 and add that count to our answer. Answer is, we can initialize our answer as number of substring. Is it making sense up till now? Any doubt? And this to this we'll add count of substrings for which mode is 2. Substrings, we'll add count of substring for which mode is 2. This is our final answer. So no doubt up till now. Okay. This function or this formula has two parts. The first part is this, the second part is this. So first of all, who will tell me how to calculate the first part? What is the value of first part? If the size of string is n, how to get the first part? How many number of substrings are there? It's n into n plus 1 by 2. Any doubt in this? Anyone who doesn't know how to calculate this? This is basically the sum of AP, arithmetic progression. If you have n places, if you start from here, there are n valid closing points. If you start from second place, that is this, you have n minus 1 valid closing points. So this way, if you count how many for each of these opening points, how many closing points you're getting, for first you got n, for second you got n minus 1, for third you'll get n minus 2, and for the last you'll get just one closing point, that is for this. So if you find the sum of this, you will get 1 plus 2 plus 3 all the way up till n. This is the sum of first n natural numbers and the sum of this is as n into n plus 1 by 2. So that's why sum of the total number of substrings in a subarray in a string is n into n plus 1 by 2. There's a doubt, what if substrings are repeating? Can you please like explain what do you mean by this? Forget about the string that we have in input. Just look, okay, forget about the string also. If you have an array of size like n, how many subarrays are there? Like this doesn't depend on the string any like it's just how many substring can you form from a string of size n. And I think this is covered in 11th class. I think it's not in 11th class. There's a math and there's a chapter in mathematics, I think it's sequence and series. In that you study AP, GP, HP, arithmetic progression, geometric progression, harmonic progression, right? So this is this thing. There are other progressions also. Does anyone remember? Other than AP, GP, HP. What other progressions are there? There's AGP. Okay, let's not discuss this. AGP is arithmetic geometric progression. It's let's not discuss that. But you should be aware of those also. Like this is like this. This is like anyway. This is very like you should remember this. There's like sum of first n natural numbers is n into n plus 1 by 2. Sum of first uh n natural number squares, like 1 square plus 2 square plus 3 square. What is this thing? Can anyone tell me? And you should also remember 1 cube plus 2 cube plus 3 cube. Like this should be on your tip. N cube. You should remember these things. These are very frequently used. Let's skip this. I'm not going to cover this. So the sum is this. If you remember it, very good. If you're not, this is the proof. Like this is basically how you get this n into n plus 1 by 2. Now, we have the first thing. Now we need the second thing. So we need the count of substrings for which the mode is 2. So for what, when is mode 2? When is mode 2? Mode is 2. Mode is 2 when for substrings when count of 0 is equals to count of 1. So now this is a very simple problem. You just need to add n into n plus 1 by 2. To this, you can add number of substrings for which count 0 is equals to count 1. How will you add count this? Like this is a very typical. Do you know how to count number of subarrays? Like with some, it's let's say sum is equals to 5. How will you count this? You'll use a map. So in this, let's say for 1, you will have plus 1. Let's replace all the ones. Like in your string, you have 0, 1, 1, 1, 0, 0, 1. So you can replace zeros with minus 1 and replace ones with 1. Plus 1, positive ones. Minus 1, positive 1. So just find how many subarrays in this array has, how many subarrays have sum 0? How many subarrays have sum 0? Because if subarray has a sum 0, it simply means have sum equals to 0. Because if subarray has a sum 0, then it simply means that that substring in the original string has equal number of zeros and ones. For example, this thing. Sum of this subarray is 0 and the substring has equal number of zeros and ones. This is just one way. If you have to find just how many count one, like how many substrings have equal number of count 0 and count 1, there are other ways also. This is one of the ways. Any doubts? Yes, I'll repeat. Okay, someone said first of all no. Like, what did you didn't understand? And like, I would prefer if you keep your like, if instead of naming anything random, you should keep your name. So if I have to, like, if like you're asking a question and I have to direct it to you, like I want to have a conversation with you, it's very difficult if you have any like random name. So like probably in future we'll like we can enforce this. Like we'll only like we'll ask you for your email IDs and we'll only allow specific those only those email IDs. Like you will have to join these PCDs only using those email IDs. So that is one thing that we can do. But okay, can't we just do count plus is equals to this? And okay, this is not what. Okay, someone said okay. Arav, you said no. So can you tell me like what is the part that you didn't understand? And also Hardik, like what do you want me to repeat? Like the mode part two after this point or for the like the complete problem? Okay, first of all, I'll repeat. See, the count two part. See, we have to count the number of substrings which have count 0 equals to count 1. So in order to do this, one way is just replace zeros with -1. Let's make an array, and for zeros we'll keep -1, and for 1 we'll have +1. So now all the subarrays for which the sum is 0, that will mean the substring, like the corresponding substring will have equal number of zeros and ones, right? Because only 1 can cancel out 0 and 0 can cancel out 1. Two zeros will never make a like a neutral sum. They will make a -2, and two ones will make a +2, not a 0. So that's why. So now how do we get like this is very simple. So see, for us, if you calculate prefix sum, the prefix sum whatever you got up till here is same as the prefix sum that you have here. Why? Because the sum of this part is 0. The sum of this part is 0. The prefix sum that you had here is same as the prefix sum that you have here. So this is a very simple technique. Just use a map. Let's say its name is sum, and calculate prefix sum from here. For each prefix sum, like increment your sum. Like you have got this much sum now. Val is my prefix sum. So whenever you reach any point, suppose your val is the sum here, just count how many times you have already received val as your prefix sum, because that would mean that all those subarrays in between have zero sum. This is a very standard technique to do this. Is it making sense? I'll show you the implementation. So this is the implementation. I have taken n and s as input. Then I have, this is my map. Sum of 0, like initially when you start, you don't have any sum. So you have 0 sum. Then your answer, currently I'm initializing my answer with n into n plus 1 by 2. I have already explained this is the total number of strings in your string. Then I'm iterating through my string as if my current character is 1, I'm increasing my prefix sum. Otherwise, I'm decreasing my prefix sum. I am not making another array. I'm just doing directly on string is increase your prefix sum, decrease your prefix sum. In your answer, like this should be done in 2 steps. Let me simplify. If you know the precedence, then it's okay. But for those, see, here we'll have sum of val. How many times I have already received val, and then sum of val. Like you have already received val once. So for future, I'm adding that. Okay, one more time I'm getting sum, like val as my prefix sum. Finally, I can print my answer. So hopefully this is clear. You can take 30 seconds, take your time, think about this. If you have any doubts, you can ask me. Otherwise, we'll move to the next problem. Okay, any doubts? Like 10, like what is the problem with 100, 1001? Like for this, n into n plus 1 by 2 can simply be calculated. Then for 1, just have +1, and for 0, have -1. And find how many subarrays are having some 0.
Actually, I didn't understood this answer, but like, don't we have to iterate over the map after this for loop, and then we can add all the sum to our answer.
Why? Like, okay. If I'm doing it like, I'll explain this. Like, first of all, doing it afterwards is always like it's wrong. Why? I'll explain. If you are at this is your subarray, and you're calculating prefix sum. So if you're at this point, you just need to check before this how many points also had the same prefix sum, right? Before this, not after this, because then you are like basically you're recounting your subarrays. You are counting your subarrays multiple times. So if this is, I'm assuming at this point my subarray ends. I have some prefix sum. I just want to check before this point how many places I had the same prefix sum, because if let's say I had prefix sum 5 here, I have a prefix sum 5 here. So this means that this subarray has sum 0. Now, how is this implemented? This is the prefix sum being calculated. Now, this is my current prefix sum. For at some index, I'll have this much prefix sum. So in my sum, which is my map, I'm saying how many places before this I had this prefix sum, I'll add it to my answer, all those positions. Because if I start at any of those positions and end at my current position, the subarray that I'll get will have sum as 0. And then for future points, I'll have that, okay, there is one more place at which I'm getting this much as prefix sum. Is that making sense? Is it like, is the doubt clear?
And why we aren't counting this current index?
Like, index is
You
not
increment,
needed, right?
yeah, like you incremented sum of value after you
Yes,
calculated the
because if
answer.
you say, if you like, if your current prefix sum is 5 and you add it beforehand, then you are like saying, okay, let's say this is your array. You are right now at this point, you have calculated sum till here, and you get prefix sum 5. Like this part is having prefix sum 5. If you add this to sum, if you do this before sum of 5 plus plus, so technically you are saying that I'll start from here and end also here. So you're not taking any elements. So of course your sum will be 0. So that's why if you do this before and then add your answer, you'll get an extra subarray. Why? Because you're taking an empty subarray in that case. If you swap these two,
Okay, so
then
yeah, the sum is like the count of index where we are starting
yes,
our subarray.
where we can start, because
Okay,
at those points we got prefix sum as 0. At those points also,
okay,
the
okay,
prefix sum was
understood.
0.
Yeah, got it, got it.
Anyone else having any doubt? Sum 0 simply doesn't mean anything. Sum 0 is prefix sum is 0. If prefix sum was 5 earlier and now again I'm getting prefix sum as 5, in between these two places, the sum is 0. Sub-array sum is 0. So it doesn't mean prefix sum has to be 0 to for the sum to be 0. Sub-array sum to be 0. Take for example, let's say there's an array 5, 3, minus 3. So the sub-array sum from second to third place is 0, but the prefix sum is not. Any other doubts? If you encounter sum 0 for the first time, you don't increase it. What? No. If you encounter sum 0 for the first time, prefix sum 0, that means from start to now, you have the sum is 0. So sum 0 is already 1 because initially I've initialized with it. So you'll add 1 to your answer and then increase sum 0. Yes? Any other doubts? Like, don't wait for others to ask your doubt. And like, don't worry that maybe you have a silly doubt. If you have a doubt, it's better to clear it right now, because after this session ends, probably you'll waste another, like, even if you have a silly doubt, you'll waste another 30 minutes.
I
Anyone
have
having
one
a
more
doubt?
doubt.
Anyone is having any doubt, you can ask me.
Yeah, I have one more doubt. Let's
Yes.
say here we had some values like zeros as well in the array. Like
Yes.
currently we are just having one and minus one. And
Yes.
let's say we had zeros as well. So
Okay.
we would include the current index as well, right?
Yes.
Like
Then
we
those
will
will
first
all
increase
get
the
added up.
sum and then we'll add up, right?
Yes, yes. So let's take this example. 3 minus 3, 0, 0, 0, 0. So what is your prefix sum here? Your prefix sum is 3. What is your prefix sum here? Like sum of 0 is initially like in my map, I have initially added for 0. I have added 1. Why? Because at start, my prefix sum is 0. Now my prefix sum becomes 3. So my prefix sum, I have received 3 ones. Now here my prefix sum is 0. So this is my answer. This is my count. How many sub-arrays have sum 0? So count should, let's keep count separately. So this is my prefix sum. This is my count of how many times I'm getting. And this is count of sub-arrays with sum 0. So prefix sum is initially 0 and there is one such point. Then prefix sum is 3, there is one such point. Then I get to minus 3, prefix sum becomes 0 and I'll say, okay, previously I had a place which had prefix sum as 0, this place. So if I start from here and end here, I will get total sum 0. So that's why I'll add this 1 to count plus 1 and instead of 1, I'll now make this 2. I have 2 points where prefix sum is 0. Now I'll come to this 0. Again, my prefix sum is 0. So I'll look how many places I have sum as 0. So there are 2 places, this place and this place. So basically, if this complete thing is having sum 0 and this is also having sum as 0, not this. So I'll add this value plus 2 and I'll increment this to 3. Then I'll come here. I'll again have prefix sum as 0. I'll then add this 3. Why? Because there are 3 subarrays which can end here and have sum 0. This, and this complete thing. Do you now get this? Yes, no?
Yeah, it's clear.
Okay. So let's go to the next problem. So this is the third problem, and in this problem, we are given that for a permutation P of size n and an integer k is between 1 and n, we define f of pk as this complex thing. What is this? This is basically I will start from 1 and we go up till n minus k plus 1 and maximum of subarray from I to I plus k minus 1. That is of subarray of size k starting from I. Now g of nk denotes the number of permutations of p of size n which have the maximum value of pk. Okay. Given a value n, find the values of g n k for every value between k, for every value of k between 1 and n. And since this can be huge, we need to print it modulo 10 to the power 9 plus 7. Well, first of all, this problem, if you read it once, like it seems very bizarre and like hard to understand. But let's follow steps one by one. So first of all, what is the definition of for permutation of p of size n and integer k, we define f of pk. So what is f of pk? Let's see. Let's define f of pk. What is f of pk? F of pk is defined as sum of max of every subarray of size k. Like basically this is in like simple language without any mathematical expression, size k. So sum of all the maximums of every subarray of size k. So if you have this thing and your k is 4, so there are these subarrays. First subarray, second subarray, third subarray, and fourth subarray. So there are 4 subarrays. There will be maximum something here. This will also have a maximum like here. This is having also maximum like here, and this is the maximum. So add these 4. This is your f of pk. now what is this thing is clear, right? F of pk is clear to everyone. Okay, so let's now look at g of nk. What is g of nk? Now there can be like, if you change the permutation, this value will change. But for two permutations can have same value of this. So g of nk is out of all permutations, permutations of p, this is of count of permutations which give maximum value of f of pk. Is it clear? If we have to maximize this thing, think about it for a moment. If you have a, if you have a, if you have a, if you have this permutation, where will you keep n? Here, here, here. Where will you keep it? If you have to take maximum of k, k sub arrays, where will you keep it? It's better to have it in between. Why? Because if you have it at last, there will be only one subarray which has this as maximum. And eventually you'll calculate sum of all of the maximum. So n should be occurring as many times as possible as the maximum value. So it's better to have it in between. But why, like where in between? If you have it in between, maybe like it's better to have it like at places at which only k subarrays will get this thing. And after a point, n minus 1 will be the maximum for next k subarrays. Is it making sense? Why k subarrays? Because n can be part of only k subarrays because the size of subarray is k. So for k subarrays, n will be maximum. For k subarrays, n minus 1 will be maximum. For k subarrays, n minus 2 will be maximum. All the way up till you will get something because the total, like how many total subarrays can be there of size k? N minus k plus 1, right? If you have 5 length array, how many 3 size subarray can be there? 1, 2, 3. So this is 5 minus 3 plus 1. So for n size array, how many k subarrays will be there? N minus k plus 1. So for k, out of those, k subarrays will have n as maximum, k subarrays will have n minus 1 as maximum. Like we'll arrange this in such order. K subarrays will have n minus 2. Then there at last, k will have something, let's say 7. And after that, like there is some value x. And after that, there will be something left, something less than k here, and it will have x minus 1. So now what we are doing, we know how many exactly, like how many are these? How many k? So n minus k plus 1 divided by k. Like these are these values. And whatever is left, n minus k plus 1 modulo k. This is basically this. Whatever is left. Not this, but this is this. And these numbers are these. Is this making sense or anyone is having any doubt? Basically, we'll arrange our numbers like in this manner. We'll have somewhere n here, n minus 1 here, n minus 2 here, like this. So that exactly k subarrays will have, this is size k, will have n as maximum, then exactly next k subarrays will have n minus 1 as maximum. Then exactly next n minus 1 subarrays will have n minus, exactly next k subarrays will have n minus 2 as maximum. So if you look at like this, how many total subarrays are there? N minus k plus 1. Out of this, k subarrays will have n, k subarrays will have n minus 1. So how many k subarrays are there? This much. And the remaining left is this thing. Is this clear or any doubt? Like why mod? Why? Because out of these total, like these are the total number of subarrays. K will be taken, like k subarrays here, k subarrays here. Whatever is not divisible by k, like total subarrays were 11 and k was 3. So 3 subarrays first, 3 subarrays will have n, 3 subarrays will have n minus 1, 3 subarrays will have n minus 2. So 9 subarrays, 2 are left, 2 will have n minus 3. So this, how does this 2 come? 2 came from 11 modulo 3. And how did this 3, like these are 3 in count. So these came by 11 divided by 3. Seal. Is it clear now? Why modulo? Yes, no. Okay. So going forward, now this is a very simple problem. Like this is how we have arranged it, right? So how many options do I have? I can rearrange these numbers among themselves. Yes, no. I can rearrange like how, like this is also having k or subarrays maximum. This is also k subarrays maximum. So we can rearrange these, right? Yes, no. What else we can rearrange? We can rearrange the numbers which are here because they are not the part of maximum. So whatever the numbers are outside this, these are the maxims. Like it doesn't matter one comes here or one comes here. Why? Because it is not a maximum. It will never have any effect. So we can rearrange those also in any order, right? Yes, no. Is it making sense? Or anyone having, or anyone is having any doubt? No. Okay, no what, no doubt, right? Now there is just one thing. There was one element which was having, there was one element, this thing, this square. This was having, this is having effect on less than k subarrays. Like n is maximum of k subarrays, n minus 1 is maximum of k subarrays. But this x, let's call this x dash, which is x minus 1. X dash is maximum for less than k, which is basically n minus k plus 1 divided by modulo k subarrays, right? Or basically I can also write this as, okay, let's write this as x dash is this. So for this, the position is fixed. I cannot say like this is my arrangement, right? I'll rewrite this again. So I had this thing. N was maximum for here, n minus 1 was here, all the way up till n minus 2, something here, and x dash is coming here. I can rearrange these among themselves, but I cannot rearrange this among this. Why? Because at this place, I'll get k, like this will be maximum for k places, k subarrays. And this is just maximum for n minus k plus 1. That is total number of subarrays modulo k. So I cannot rearrange this, but I can rearrange this out of all of these places. I can rearrange it here and there, right? It is only like I can move this along these as long as it is in each and every subarray, right? Yes, no? Is it making sense? Like these can be arranged among themselves in any order. The values that are here can be rearranged among themselves, but this x can be rearranged only as long as if it is within these subarrays, these 2, 3 subarrays, which is exactly this thing. X dash is whatever is here, this thing. Is this making sense? Or there is any doubt? Like simple thing, right? You cannot say that I can rearrange x dash and n minus 2 also, because n minus 2 is maximum for k sub arrays. X dash is not for that much. So that's why. So what I can do, finally multiply the number of ways in which, for which x dash can be there. So first multiply all the number of ways in which I can rearrange these numbers. So let's say it is, these are, let's call this temp. Temp is temporary variable is n divided by k. Total number of these. Like this is k for k sub arrays. This is also k. This is also k. Same thing as whatever what I have written here. N minus k. This thing. Like you write n minus k plus 1 by k or n by k. So you'll get the same thing. So you have, you'll do n by k, you'll get the number of places at which you are getting these, calculate the factorial of that, multiply it with these, like all the numbers which are outside this. So they can be calculated as n minus, let's say this is temp. So n minus temp factorial, right? I have not written it. All the remaining numbers, temp factorial. And finally, multiply this with all the options at which x dash can be there. So x dash can be there at k minus the places, like k is the size of the subarray. And how many places it can be? N modulo k. Same thing as this. What we had written here, this thing. Like this is the number of subarrays, right? So this thing. K is the size of the subarray. We cannot move it outside these places, because then it will be maximum for more than the number of subarrays we want it for. So calculating factorial for every test case, since we have a fixed maximum value, so we can calculate pre-calculate factorials and then use it. So let me show the implementation. Like, see, we have taken the number of test cases as input, then we have calculated factorial for every value between 1 and 10 to the power 6. Then for each test case, take n as input, find what is the temp n divided by I, calculate the remaining, whatever will go to x dash. Like how many subarrays will be there for which x dash is maximum. X dash is the last maximum value, smallest maximum value. So n modulo n. N modulo k. I is basically k here, the subarray size. Then my answer is initially factorial of temp, that is the number of ways to rearrange from n to whatever your x dash is, basically more than x dash plus 1, from n to x dash plus 1. This is the number of ways to rearrange all the remaining elements. And finally, this is the number of ways to like the number of places at which you can have x dash, k minus the number of subarrays for which x dash will be maximum. Finally, we can print it. Is it clear? Like take at least 1 or 2 minutes and then we'll get back. Okay, someone asked why we are taking n by k and not n minus k plus 1. What is, like, if you are given a by b and you have to calculate c, how will you calculate it? You'll calculate it as a minus b plus 1 by b. This thing. Like it is basically the same thing. If you have to calculate a by b, seal, it is simply a minus b plus 1 by b. You can verify this. So we don't actually have to write this thing. If we are writing A by B integer division, we'll get ceil only, not ceil, floor. This is floor, right? So we'll get floor only. No, I think I messed here. I meant ceil, not floor. This is for floor, ceiling, not flooring. Like if you have to find floor, if you have to find ceil of A by B, we do A plus B minus 1 by B, right? This is for this thing. Yes, no. Now, this is making sense to everyone, right? This everybody knows. Yes. So now, total number of subarrays. How many total number of subarrays of size k are there? N minus k plus 1, right? But how many places? What are we actually finding here? How many places? We are not finding like out of n minus k plus 1 subarrays. How many places at which we can give these? So these will be at regular k intervals, right? So that's why n by k. These maximums will be placed at exactly k interval. By k interval, let me explain. Like I'm sorry, like whatever is like this has no meaning. Like this is basically this. I don't think this is anything. See why n by k? Because if you have this thing and you have a maximum here, so basically k is 3. So after exactly this point, the this will have this will be maximum for 3 places, and the next subarray, which is this thing, will have this as the maximum, right? This next as the maximum. So what is the difference between these two? 3. So every maximum will be k distant apart. So how many maximums can be there? N by k. Is it making sense now? That's why n by k. And why n minus n by k? Just the remaining elements that don't matter. Is it clear now? If there is no doubt, we'll move to the next problem. You can take 2 or 3 minutes. The last part is, suppose x dash is the lowest minimum. You can keep it, like you don't have to keep it at that place only. You can move it. And remaining is the number of subarrays for which x dash is maximum. I is basically k. So k minus the number of subarrays for which you want this maximum is the place you can move this around. This doesn't need to be maximum for k subarrays. See, let me depict this using some. See, if k is 3, you need to place this at center, this n. But x dash, let's suppose this is x dash. I need this to be maximum for 2 only. K is 3. So I just need this to be maximum for these two subarrays. This and this, not this. This subarray is not there, for which I want this maximum. So x dash can either be here or x dash can either be here. Both will satisfy, right? Yes, no. But not in case of n or n minus 1. Because those have to be maximum for k subarrays, but not this. So that's why multiplying like these options, where x dash can be. So these needs to be multiplied here. So k is the total size of subarray. Remaining is the total number of subarrays that you want this to be maximum of n modulo I. Is it clear? And what is factorial term? Total number of ways to rearrange these maxims. This is the elements that don't really matter. So arrange them in any order. Clear? So take 2 or 3 minutes, like take 1 minute, and if it's clear, then we'll move ahead. Okay, let's go to the next problem. So in the next problem, we are given that we have an array A of size n. We can rearrange the elements of A as we want. And after that, we construct another array B of size n such that B1 is A1. And after that, BI is simply BI minus 1 and AI for every I between 2 and n. We need to find the maximum or the lexicographically largest possible array B. So let me explain this problem. See, we are given an array A. We can rearrange this. And after that, we need to construct another array B. So for constructing another array B, we have B of 1, like the first element, B1, or let's say B0, B1 is A1. And after that, BI is simply always BI minus 1, whatever BI minus 1, whatever the value was up till now, and AI. So this way, we need to construct the maximum, lexicographically maximum array. Now, usually, like what comes to your mind? B1 should be what? Anyone? Like forget about anything, every other element. What should be B1 if you are given array A? It should be the maximum of the array. So your B1 should be maximum of array A. Why? Because you have to get the lexicographically maximum array B. Lexicographically largest array B. Then what should be your B2? Your B2 should be such thing that it's maximum. So in order to maximize it, you should find a array AI for which AI and B1 is maximum. Yes, no. Yes, no, anything. Okay. But now let's say how to find this. One way is brute force. Just iterate through the complete array, find a suitable I and calculate B2. But let's say there are two elements or two or more than two elements for which we are getting the maximum. So how to decide which to choose? Actually, it doesn't matter. Why? Because B2 will have a certain number of bits set, and those bits are indeed going to be set in all three. If you had three elements, three candidates, those three will be set like since the max, like this value was equal for AI1, AI2, and AI3. So all of these will have those bits set because the AND was same. So after this point, only these bits are set. So it doesn't matter if you pick AI1, AI2, or AI3. After this point, so the brute force solution is clear, right? Just find the maximum like whatever is getting you the maximum and keep it at this at that point. Is the brute force solution clear? Now, how to reduce the time complexity? What we can do? See, your elements are between 1 and 10 to the power 9, 2 to the power 30. So there are at max 30 bits. So after some like either your AND is not changing, or once it changes, your at least one of the bits will be unsetting. Like your one of the bits will be unset, will become unset. Right? Yes, no? Yes, this is what will be happening, right? First your AND will not change, then your one of the bits will become unset, one or more. Then again, for some time your AND will not change. Then again, your one or more bits will unset like this. So this is how your array B will look like. Yes, no? Because we are taking prefix and. So how many times this thing can happen? One or more bit will become unset. At max 30 times, because there are maximum 30 bits. So simply what we can do, we can start from first, like we can start from maximum element of A. Just find all the elements for which your bit is not like your AND is not changing. Keep them next to the maximum element in A. And after that point, your bit is anyway, one of the bits is going to change. So find the maximum element here. Get your maximum element, maximum, like the element which is resulting maximum and keep it here. And by the way, this is same as maximum element because it will have the maximum bit set. So get the maximum element, keep it here, or the maximum element, which like the element which is giving you the maximum and keep it here. Again, do the same thing. Keep all the elements for which the and is not changing. Again, your and will change. Get the element which is having the and result maximum. So how many times will this operation become? Will be computed 30 times, right? Because after 30 times, all your bits will be unset. Yes, no? So this is the solution. Is it clear? Like we get the and how to find, just simply iterate through the array and check what is your and. If it is not changing for those elements, and keep including them. Like those elements can be in just one iteration, you'll get all the elements. So you for every element you don't have to iterate. All those elements you will get at once. So let me show you the implementation. So first taking the array A as input, finding the maximum element. This is my answer. Currently, this is what I have, what I'll use to find the and. Then I'm iterating through the like 32 times. This is my temporary vector B, and this is my check. So iterating through array A, finding what is, if my and result is not changing, then I'll include the current value in my answer. Otherwise, if it changes, I'll insert it in B. Like for all of these values, my and is changing. And I'll also calculate what is the maximum and that I can get. After that point, I'll update my like all those elements which for which my answer like my and was not changing. I've already inserted in those in answer, and these are the remaining elements. So remaining elements are now A. Like I've updated my array A. Temporary array is cleared. B, and I again iterate through AY because I have to find the next element which for which I was getting this maximum. So we can do it here also, by the way, here only. But I have iterated again, found the element, inserted it in answer. Value is now like the prefix and is now this thing, basically this thing. And check is again set to -1. Otherwise, as long as I'm not finding that element, I'll insert it in B only. B is the temporary. And after this point, all the elements either for which my and was not changing are in answer, and the element for which I was getting maximum and
is also inserted in answer. So all the remaining elements are in B. So these are the remaining elements. Finally, for printing the answer of all the elements of A are pushed, all the remaining elements of A are also pushed in answer. After a point, I get this as 0. Like my AND becomes 0. So all the remaining are pushed into answer and just calculate prefix. And because this is how you'll arrange your array A, but this is how you calculate prefix and that is your array B. So you can print it. Is it clear? Like if you have any doubts, you can ask me. Just take a look at the solution. It is just simple, like iterating twice. Just how will you decrease the time complexity of the initial proof for solution? Okay, got it. So, okay, if there is no doubt, we can stop. So, thanks for joining and bye-bye.